Your attic is an oven right now. On a summer afternoon, the air inside an unprotected attic reaches between 150 and 170 degrees Fahrenheit. That is not outdoor temperature. That is the temperature of the air sitting directly above every room in your home right now, and that superheated attic air radiates downward through your ceiling continuously, heating every room below it like a slow cooker operating 24 hours a day. This is why your upstairs rooms never cool down even when your air conditioner runs constantly. This is why your electricity bill climbs every summer no matter what adjustments you make. This is why professional HVAC technicians keep telling you to upgrade your system rather than explaining the actual source of the problem. There is a $3 fix that stops this permanently. It is a thin, reflective material that has been available at every hardware store since 1953. When installed correctly in your attic, it blocks up to 97% of the radiant heat your attic generates before it ever reaches your ceiling. A government study at the Florida Solar Energy Center documented this exact result in a controlled residential test spanning 2 full summer seasons. Roofers and insulation contractors have known about this material since it was first manufactured. They do not talk about it because a $3 fix you install yourself in an afternoon is not a service contract. Welcome to Vault Breaker, where we open every vault that billion-dollar industries paid to lock shut. Subscribe and ring the bell right now because what you are about to learn changes every room in your home starting this weekend. Here is the physics that the roofing and insulation industry has never explained clearly. Heat travels in 3 ways: conduction, convection, and radiation. Standard attic insulation, the pink fiberglass or blown cellulose installed in most American homes, addresses conduction and convection reasonably well, but it does almost nothing against radiant heat. Radiant heat is infrared energy that travels through air without warming the air itself, directly from a hot surface to any cooler surface it can reach. When your roof surface reaches 160 degrees in direct summer sun, it radiates that heat downward through your attic space continuously. This radiant heat passes through your standard insulation without difficulty and reaches your ceiling, warming every room below. Your air conditioning system then has to fight against this constant radiant heat load pouring through your ceiling every hour of every summer day. This is exactly why homes with excellent standard insulation still overheat in summer. The insulation handles the convective heat transfer adequately. The radiant heat passes through it entirely untouched. Now go back to 1953. A materials engineer named Walter Reginald Barnes was working at a research facility in Huntsville, Alabama, developing reflective barrier materials for military applications. Barnes documented that a thin layer of polished aluminum, when placed with an air gap facing the direction of incoming radiant heat, reflected between 95 and 97% of that radiation back toward its source before it could transfer to the surface behind it. His findings were published in technical materials, journals, and subsequently adopted by the aerospace and military construction industries for thermal protection of equipment and structures. By the late 1950s, several manufacturers had begun producing consumer versions of this reflective barrier material for residential attic installation. The product was inexpensive, lightweight, and dramatically effective. Early case studies from homes in Florida and Texas documented reductions in attic radiant heat transfer of over 90% following installation. The Florida Solar Energy Center, a government research institution, conducted a comprehensive 2-year residential study in the 1990s, measuring the impact of radiant barrier installation on whole house cooling costs. Their published results found that homes with radiant barriers installed in the attic use between 17 and 42% less energy for air conditioning compared to identical homes without radiant barriers. The variance depended primarily on local climate conditions and the specific quality of the installation. In hot, sunny climates like Florida, Texas, Arizona, and California, the upper end of that range was consistently documented. The Department of Energy cited this study in its residential energy efficiency guidance documents. Yet the vast majority of American homes built since 1953 have been constructed without a single square foot of radiant barrier installed in the attic. Here's exactly why. The residential roofing and insulation contracting industry generates over $60 billion annually in the United States. Their business model depends on selling materials and labor for products that require professional installation, periodic replacement, and ongoing service relationships. Standard fiberglass bat insulation installed by a contractor costs between $1,000 and $3,000 for a typical attic, requires professional installation for warranty coverage, and degrades over 10 to 15 years, requiring replacement. A roll of radiant barrier material costing $3 to $8 per square foot at bulk pricing, or available in smaller quantities for a weekend DIY project for under $20 total for a small attic section. Installs without professional tools, without technical training, and without ongoing maintenance or replacement. A material that a homeowner installs themselves on a Saturday afternoon, never replaces, and sees immediate results from, is fundamentally incompatible with a $60 billion industry built around recurring professional service revenue. So, radiant barriers disappeared from standard residential building practice almost entirely after the early 1960s. They remained in aerospace applications, in commercial building design, and in the professional knowledge base of every experienced building scientist in the country. They simply never appeared in the residential building code recommendations that govern what gets included in new home construction by default. Think about every summer your attic has been sitting at 160 degrees above your living space. Think about every room that has been too hot to sleep in despite a running air conditioner. Think about every electricity bill that seemed unreasonably high for what your system was actually delivering. Think about the professional HVAC technician who recommended a larger system, new ductwork, or additional insulation, and never once mentioned that the source of your problem was radiant heat passing through your ceiling untouched. Every dollar of unnecessary cooling cost you have paid since you moved into your home has been partly a consequence of a $3 material that was never put in your attic. If you have made it this far, you already understand the attic heat problem more completely than most homeowners who have been paying to fight it for years. Subscribe and share this with every homeowner you know who is suffering through this heat wave right now. Because every day their attic sits at 160 degrees above their living room is another day of unnecessary electricity costs that a $3 fix would stop permanently. Now stay with me, because here's exactly what to do this weekend. The material you are looking for is called radiant barrier foil insulation, also sold as reflective foil insulation or attic radiant barrier. At hardware stores, a standard roll covers 250 square feet and costs between $25 and $40. For a quick, effective partial treatment targeting the most critical section of your attic, a smaller area covering the floor of your attic directly above your most used living spaces can be addressed for under $20 in materials. You do not need to cover your entire attic to see meaningful results. Covering the area of your attic floor directly above bedrooms and main living areas addresses the most impactful heat transfer points first. Roll the reflective material across your attic floor between the joists, shiny side, facing upward toward the roof. This positioning places the reflective surface facing the incoming radiant heat from your hot roof, bouncing that heat back upward before it reaches the insulation and ceiling below. Secure the edges with standard staples or aluminum tape. No adhesive, no professional tools, no special training required. Ensure there is at least a 1-inch air gap between the reflective surface and any material it faces, because radiant barriers require an air gap to function correctly. They reflect radiation across the gap rather than conducting heat through physical contact. Work in the early morning when attic temperatures are manageable. Do not enter your attic during peak afternoon hours when temperatures approach dangerous levels. Complete the installation in sections across early morning days, working gradually from the areas directly above your most used rooms outward. I want to be completely honest about the one limitation this material has. Radiant barriers are most dramatically effective in climates where summer cooling is the dominant energy concern, meaning hot, sunny regions where the roof surface regularly reaches extreme temperatures. In cooler climates, where heating dominates energy costs, a radiant barrier in the attic can slightly reduce beneficial heat gain in winter, which is why it is most strongly recommended for warm climate states rather than northern states where winters are severe. If you live in a climate that is primarily hot, this material is one of the highest return on effort investments you can make in your home's thermal performance. A homeowner in Orlando, Florida, installed radiant barrier foil across the attic floor above his main living area in June of 2022 using $38 of material purchased on a Saturday morning. His living room, which had previously reached 89 degrees by 4 in the afternoon despite continuous air conditioning, measured 78 degrees at the same time the following week. His July electricity bill for that summer was $112 compared to $179 the previous July under similar outdoor temperature conditions. $67, saved monthly from $38 of material and 4 hours of early morning attic work. Walter Barnes documented the reflective barrier principle in 1953 for the military. The Florida Solar Energy Center confirmed 17 to 42% cooling cost reductions in controlled residential testing. Every building scientist who understands residential thermal performance knows that radiant barriers belong in every attic in hot climates. The $60 billion roofing and insulation industry knows it too. Your attic is sitting at 160 degrees above every room in your home right now, pouring heat through your ceiling hour after hour, summer after summer. The $3 material that stops it permanently has been sitting on the hardware store shelf since 1953. Today, you just learned everything the roofing industry spent 70 years hoping you would never understand. If this vault opens something for you, subscribe and share it with every homeowner you know before this heat wave gets any worse. Every share puts this knowledge in the hands of someone whose attic is cooking them alive right now. The next vault opens soon, and what is buried inside it has been hidden from homeowners even longer than this one has.